So I would love to introduce Ken Brandt, the director of the Robeson Planetarium and Science Center, found here in North Carolina in Lumberton. So welcome, Ken. Everyone say hi to Ken.
Good afternoon, everybody. I'm going to start you off with a question. And if you'll just type your answer into the chat, all right, I would like you to tell me what my favorite planet is. It's very
Oh,
simple. Of the planets we know about, which one is my favorite?
this is a trick question, Ken.
No, it's not. Some of the questions in science are smack easy. This is one of those.
Okay, I'm seeing Mars, Neptune, Jupiter. Lots for Jupiter.
Jupiter's fourth on my list.
I'm seeing Venus, Uranus. Oh, Earth? Could it be?
Ding,
Oh, someone said all of them. Is it Earth?
ding, winner. Earth is my favorite planet. Now, big question is, and you don't have to type this answer in. Think about it for a second. Think of why I might favor Earth over all the other planets, given all I know about planets, because I know a little bit. I study these things, and so I know a lot about the planets and their moons, but Earth is by far my favorite. And maybe a couple of you, if you want to throw in the chat, why you think that is. Why do you think Earth is my favorite planet?
Praneeth says it is our home.
It is our home. That's
And
certainly, this is one of those answers. If I was grading a test, there would be lots of correct answers, by the way.
yeah.
So it's
I'm
really hard to get
seeing,
this one wrong.
yeah, Troy said weather is nice and the restaurants are good. But most other people are saying because, Earth is habitable and we can have life here.
Yeah, when I go to work, it takes me less than an hour from bedside to desk side, you know, at work. And that includes a half an hour commute. I don't have to do a whole lot of preparation to go out into the environment in this part of Earth anyway. I might have to do a little more if I live, say, in Nome, Alaska, but here, work is not that hard to get to, and I don't have to wear a spacesuit when I'm going to work. If I was going to work on Mars and I lived in a different building and worked in a different building, I might have to don a spacesuit to go outside, and that provides an extra layer of complication I just don't need. Thank you. So I'm a huge fan of exploring Mars. Don't get me wrong. I want people to go. I want Elon to do everything he's doing and get there. But I don't want to go. you know, I'm going to stay here and talk about it and tell everybody else what's happening and tell the story. Um, so we're going to talk today about my favorite moon, which is Europa. And does anybody have a guess as to why Europa is my favorite moon?
Oh, why is Europa Ken's favorite moon? Antonio says water.
Mm-hmm. Good.
So possibility for life.
Mm-hmm.
Yeah.
How many of you are familiar with science fiction, specifically Arthur C. Clarke, and a series of books he wrote and movies which came out after them that started with 2001: A Space Odyssey?
Yeah. I'm seeing uh Carol Barstow said has a nice name. 2010. Yeah. Did they get
Mhm.
to mm-hmm.
Yeah, 2010, and then in the novel 2010, we make contact with an alien civilization, and their response to us is, you can do anything you want with all these other worlds, but attempt no landing on Europa, or something to that effect. So Europa is very much off limits to us, and they don't tell us why, and you never really find out why that is. So, all right, so my logos are here. I forgot to put my email address in here. So what I'll do is I'll throw my email address in the chat if that's okay.
Yeah. Do you want us to do that for you?
Oh yes, please. If you just
Yeah.
throw my email address in there, so people have it if they want it, and also if museum staff, if we run out of questions or run out of time, if people have more questions, they can email me, or the staff, the Carrie or somebody can email me with the
Sure.
questions. So if we
Absolutely.
don't get them, if we don't get, my goal is to answer them all today. Failing that, then we'll do, you know. All right, so let's talk about what's happened and what's happening. What's happened, Jupiter and the Jupiter system, because you really have to think of Jupiter like its own mini solar system. Now, Jupiter commands on any given day the most or the second most moons in the solar system. That depends on who's observing with what and how we're counting moons. Okay. Jupiter has something like 79 moons. It could be 80 now. I don't know. The number keeps on going up all the time. Well, this is the shadow of Jupiter's moon Europa on Jupiter. And this was taken by the Juno mission, which is the current mission flying around Jupiter right now. Now, Juno just got extended. NASA does this thing where when a mission completes its primary mission, it goes for extended funding and extended operations. And the Juno spacecraft is working beautifully. There's no major issues with it. And it's been flying around Jupiter now for about 3 years. And it finished up its prime mission. And this year, Congress and NASA authorized it for, I think, a 3-year extension in its mission. And part of that extension is going to be doing more flybys of Jupiter's moons. Mostly it's been doing flybys of Jupiter or orbiting Jupiter and taking lots of detailed images of Jupiter and doing analysis of its radiation fields and other things around Jupiter. But the extended mission is designed to do more flybys of the moons, including at least 4 flybys of Europa. And so we'll wait expectantly for more information. And NASA's rule is very simple. If you have a working spacecraft at a destination doing good science, you continue running the spacecraft until it stops working. And that's exactly what they're going to do with Juno. They've extended it so the scientists can all get paid, everything like that, for at least 3 more years. So Juno is still going. Before Juno, we had Galileo in the late 1900s and early 2000s, which was orbiting Jupiter and did several really nice flybys of Europa. A lot of the images of Europa you're going to see today are actually from Galileo back about 20 years ago, or a little over 20 years ago. Before that, you had the 2 Voyagers. And I forgot, in 2006, New Horizons flew by Jupiter on its way to Pluto and actually got a gravity assist from Jupiter to throw it out towards Pluto faster. And so that happened back in 2006 or 7, I think. I think it was like January of 2007, if I recall. But it was right around that time. Before that, you got the 2 Voyagers, Voyager 1 and 2, and also the 2 Pioneers, Pioneer 10 and 11, which first started flying by Jupiter in 1977. So Jupiter's been getting explored, and the Jupiter system has been getting explored by spacecraft now for over 40 years, almost 45 years.
Wow. And Ken, do you mind answering a couple of quick questions general about Jupiter? Okay. So first off, just to clarify, in that picture just now, the black dot, that was a shadow from Europa, correct?
Yes, this is the Europa shadow being cast onto Jupiter's surface.
Okay, just to make sure. And then some are saying that, just reminding us that Jupiter has the great red spot. Mm-hmm. And is Jupiter growing another red spot? And, are those red spots kind of shrinking or changing as far as you know?
A couple of years ago, I'm trying to get an image of Jupiter. I guess that's the best one we're going to get. These cloud patterns do change over time. The red spot, the great red spot, has been persistent now for over 300 years. I think it was first seen by Herschel back in the early or mid 1600s, or Huygens, one of the two, and has been seen on Jupiter ever since. And it changes slightly in dimension, in color. Sometimes it gets a little darker red or lighter red or a little paler around the edges. But like this is not the great red spot here. It's just another red spot on Jupiter. And so these cloud formations, these hurricanes essentially, form all the time in this turbulent atmosphere of Jupiter. So yeah. But I don't know enough about Jupiter's atmosphere. I'm not the guy to ask that question of.
No, that's okay. That answered my question. Yeah.
Okay. Are there any more, or should we go on?
No, I think we can go on. We'll get to, if I see any more questions, we'll get to those later.
Okay. So surprisingly, it surprises me anyway that we can still use solar power to run spacecraft like Juno and Europa Clipper. Both of these use solar panels. So these panels have gotten a lot more efficient since NASA started using them in the 60s, I think even the late 50s. They've gotten a lot more efficient because you have to understand the solar intensity, the radiation of the sun, is 1/25th of what it is here on Earth, roughly 1/25th or 4%. So the panels have to be incredibly efficient to draw enough power to run all the systems on the spacecraft, which is interesting to me. I always find this fascinating.
Yeah.
But you can't send solar panels like on a trip to Pluto, for example. At some point, you get to the point where the sunlight is too weak to provide enough electrical power to make it worthwhile. So this is Europa. Um, it's a global picture. It was taken by Galileo, I think, in 1999 during a close flyby. And the first thing you notice about Europa is it's cracked. There's a lot of cracks in the surface of Europa. The second thing you should notice about Europa, and you kind of have to pull together an image of the moon in your head. All right. So our moon, the Earth's moon or Luna, put an image of Luna there in your head and compare it to Europa. And what's Europa missing that the moon has a lot of? What are we missing here? Somebody could throw that in the chat.
Okay, so what is Europa missing that our Earth has? Oh, or our moon has, excuse me, craters. And
Lots of
also
craters.
gray. Yeah, the color's
Good.
different. Mm-hmm.
Good. So the two primary things you notice, or you should notice, if you're comparing these two objects, the color, of course, and then the craters. We're missing the craters here. And so whenever you see a surface like this, a solid surface, and it doesn't have craters, or it doesn't have very many, there's a couple, just like this one right here, for example. There's a few, but not nearly as many as you'd find per square meter on the moon. Okay, so the question you have to ask yourself is what's going on the surface to erase that record of cratering? Because from what we know from solar system exploration now, from everything from Mercury on out to Miranda, out at orbiting Uranus, is that solid surfaces left undisturbed show this record of cratering that seems to have happened around the same time, around 3.7 billion years ago. And we call that the late heavy bombardment. Okay. And I should have put that in the jargon thing. But late heavy bombardment, it was a time when a lot of craters were happening all over the solar system, a lot of impacts. A lot of objects were coalescing and becoming bigger objects, and they did that by mushing into each other and leaving a mark when they did. And that mark, of course, is the crater. Like Mercury, for example, covered with craters, okay, and geologically dead. All right, Mercury doesn't have a whole lot going on since it formed, 4.6 billion years ago. All right, except for those records of cratering and occasional crustal depressions in places and stuff like that. Likewise, the moon. The moon has several really big craters that release lava fields when they solidified, and those become the mares, or the open areas on the moon that are darker and look like seas. That's what Galileo called seas on the moon when he saw them through his telescope. Um, so the moon has basically remained unchanged over that period of time, but places like the Earth and Europa and Enceladus and other places have parts or all of them that have very few craters on them. And so the question you have to ask is what's happening here? Okay, so does anybody know why Europa doesn't have very many craters?
Let's see. Why would it not have craters? So Ian is thinking, it's got ice on it, maybe, and that the ice kind of heals, covers up.
Okay.
Jasper says volcanoes. Barton said the weather. Praneet says maybe it's not hit by a meteorite. Ruxin said Jupiter's gravity. Sorry, yeah, lots of good answers here.
Yeah, lots of good answers, but not quite the one I'm looking for. All right, what we're looking for here is you have to think of Europa like the shell of an egg, okay, or an egg. All right. Now, a raw egg, okay, you've got a thin shell, and then underneath that thin shell, you have liquid. And what happens is gravity. You got the three other Galilean or big moons of Jupiter orbiting Jupiter. sometimes getting closer to Europa, sometimes getting further away. And you've got the planet Jupiter itself. Okay, as Europa orbits Jupiter in its ellipse, Jupiter tugs on it stronger in one direction than it does another because it's got a part that's facing Jupiter and a part that's not. And that causes bending and cracking of the ice. And when the ice cracks, the liquid underneath spews out. Okay, in the same way, if you crack an egg, liquid comes out, right? Well, the liquid comes out, and in this part of the solar system, it's very cold. All right, I'm not sure what the temperature is out here, but I think it's around minus 200 Fahrenheit. It's really cold on the surface of Europa. So the minute that water gets out there on the surface, it freezes. Okay. Now the question is, in this false color image, which is enhanced so we bring out some of the features of these cracks and some of the stuff that's in the water, um, the thing is that when it cracks, any record of cratering that might have been anywhere near that crack is literally washed away and then covered up by a fresh layer of ice. And the ice isn't clear like you might expect. The ice turns a kind of whitish blue color, and in this false color image, and the ice is kind of red or orange up here, around these cracks up here in the northern part of Europa. And so the big question is, what makes it orange, right? Turns out those are organic molecules. Okay, when I say organic molecules, I'm thinking like the chemicals that make up your body and mine. Okay, those same simple chemicals in most cases are what's being laid out on the surface of Europa. And we don't know beyond a very surface survey of what those chemicals are. And so part of the Europa Clipper mission is obviously to find out more detail about the structure of the sludge that's on the surface of Europa. Okay, so there's a couple of videos I'm going to show you. All right, this is the first one, and it talks about Europa as an ocean world. Oops. Okay, sorry about that.
No worries. It was working well before then, which is good.
Go back to there. And I just want to make sure you're seeing an image and hearing music.
Yep.
Okay, good.
The search for life beyond Earth begins with understanding life on our home planet. And that story, the story of life on Earth, may have begun in our oceans. And that's because, of course, if we've learned anything about life on Earth, it's that where you find the liquid water, you generally find life. So what if I told you that there is an ocean out there beyond Earth, an ocean in our solar system that has been in existence for billions of years? It's an ocean that is perhaps 10 times as deep as Earth's ocean. It's an ocean that is global and may contain 2 to 3 times the volume of all the liquid water on Earth. It's an ocean that exists beneath the icy shell of Jupiter's moon, Europa. So how do we think we know that Europa's ocean exists? Well, it's a combination of using telescopes on the ground and having spacecraft that have flown by Europa and collected data about the surface, about the interior structure, and about the magnetic field around Europa. And the combination of those data sets leads us to a high degree of confidence that this global liquid water H2O ocean is there today, and it's been there for much of the history of the solar system. We used to think that in order for a world to be habitable, you had to be at just the right distance from the sun or whatever your star was, such that you could have a liquid water ocean on the surface. Now, along with liquid water, life as we know it needs 2 other keystones. The first is the building blocks for life, the stuff you find in rocks. And the second is some form of energy to help power life. And here's where Europa is a real game changer. It is far, far out from the sun. And yet it's got this liquid water ocean. And the reason that Europa has liquid water is because it's orbiting Jupiter, and the tidal tug and pull causes Europa to flex up and down, and all of that tidal energy turns into mechanical energy, which turns into friction and heat that helps maintain this liquid water ocean beneath an icy shell. Along with helping maintain liquid water, we think that tidal energy may also allow that ocean to interact with rocks on Europa's seafloor. And it may even give rise to things like hydrothermal vents, which could help provide not just the building blocks for life, but also the energy for life. The question of whether or not life exists beyond Earth, the question of whether or not biology works beyond our home planet, is one of humanity's oldest and yet unanswered questions. And for the first time in the history of humanity, we have the tools and technology and capability to potentially answer this question. And we know where to go to find it. Jupiter's ocean world, Europa.
Okay, so the next video is more concentrated on the mission itself.
Europa is the most likely place to find life in our solar system today because we think there's a liquid water ocean beneath its surface. And we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
We might be actually looking at a body that is presently alive, presently active, and presently undergoing its geology. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. Is that an environment that is habitable for any sort of life form? By golly, we really have got to go back and figure that out.
We have designed the Europa mission to take a spacecraft and a set of instruments all the way from planet Earth to Jupiter.
Previous mission concepts were for a spacecraft that would orbit Europa, but Europa is bathed in radiation from Jupiter. Any mission that goes in the vicinity of Europa is cooked pretty quickly. Instead, we're looking at a mission that will orbit Jupiter, make close flybys of Europa, and then zip out of the high radiation region.
Kind of like when I was a kid, we had the sprinklers, and we didn't want to be too close to the sprinkler head, so we would run in and get a little water and then run back out again.
This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes, and we could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat and do this many, many times until we understand Europa globally. Images from the Hubble Space Telescope tells us that Europa might be erupting plumes of water high into space. If that's true, then we could fly through those plumes with a spacecraft and literally taste it to understand the composition of Europa's interior.
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy and beyond.
Lots of excitement here in the chat, Ken, about
Excellent.
both
Okay,
videos.
so questions, anyone?
Yeah, so Carl asked, how often does Europa circle Jupiter, and how often does Europa rotate on its axis?
Carl, you asked the question, and I completely forgot how long it takes Europa to go around Jupiter. I want to say 6 days, but you really need to look that one up. I'm sorry. I don't know that. I feel really bad because that's what I'm talking about. But I do know that Europa is tidally locked with Jupiter. That means the same side of Europa always faces Jupiter as it's orbiting. So the rotation and revolution periods would be almost equal. That much I do know.
That is really awesome. And someone else, one of our friends, asked, how long does it take to get to Europa?
It depends. A typical, like Juno launched in 2012 and arrived at Jupiter in 2017. So roughly 5 years by current technology. It can take slightly longer or shorter depending on the type of rocket that actually launches it from Earth, and how much how much thrust that rocket can generate as it's leaving Earth. In other words, how fast the probe can go, get pushed into insertion towards Jupiter. But the other thing we rely on a lot of times is gravity assists from Venus, occasionally Mars, but way more often Venus and Earth itself. When Galileo went to Jupiter, it flew by Venus twice and Earth once, I think, on its way out to Jupiter, just to gather up the necessary speed to get all the way out to Jupiter.
Wow. And we did have this answer in the chat, and I looked it up real quickly just to double check, but it looks like 1 year of Europa. So the amount of time it takes to go around Jupiter is 85 hours, or about 3.5 days.
Okay, good.
So yeah,
whoever looked that up, thank you very much. I apologize again for not knowing.
I'm not good with numbers. I'm the same way if I and let's see, another friend was wondering, have you heard of the hypothesis that the red cracks are due to a certain type of whale feces / microbial life? They think it was published in the journal Astrobiology in the early 2000s.
It's entirely possible. Your guess is as good as mine, probably better, especially if you've got a referee journal to back yourself up with, like Astrobio is a good one. So whale feces is one possible explanation. There's all kinds of possible explanations. The simplest is probably low-order microbial life, like algae or something like that, getting spewed out from the ocean onto the surface. But no one really knows for sure because nobody's been able to get close enough to this stuff. What you want to do is put a lander down here. And ideally, a lander, there's been some technology investigated, and they've actually tried this in Lake Vostok in Antarctica. I think the Russians are working on this. A nuclear-tipped probe that would be dropped into the ice. The heat from the radioactive decay melts the ice in front of it. And then when the probe gets into the lake proper, or the ocean in this case, it releases a submarine. And then the submarine, of course, starts doing the video thing. And it takes pictures and images and does spectrometer readings and all that, and sends it back to Earth. The question is, how do you communicate through the ice effectively? And then the second question is, how do you actually go through, and where do you drop the probe so you spend the least amount of time burning your way through the ice or melting your way through the ice? So there's a lot of question right now as to how thick this ice actually is. Now, of course, the ice is probably going to be a lot thinner in some of these more recent cracks. But, the question is, it, a couple of kilometers, is a couple of 100 kilometers? They're still working that one out.
And we've got some observations that that the red color kind of looks like blood. So like perhaps it could be like iron, like that's found in our blood. I was also thinking that it reminds me of some of those algae blooms, that we hear about here on Earth. Yeah,
definitely. That red color definitely could be algae blooms. Again, we're all speculating right now. Until we get a lander down there to actually examine it up close, and the way you do it with a Mars rover, we're really ballparking. Even a low orbit spacecraft, Clipper is going to, one of its flybys actually takes it within 16 miles of the surface, which is pretty close for an object flying around, supposedly flying in the atmosphere, or above the atmosphere in space. 16 miles is very close. To give you an idea of comparison, the space station orbits around 220 miles up. So 16 miles above the surface would be really close, and you get some really detailed images, but still not detailed enough. Even with the best camera you can put on the Mars Reconnaissance Orbiter, the best it can do is about 3-foot resolution on the surface of Mars. So, here we're talking, I don't know how many, I don't know what the resolution of the cameras will be when they launch it in 2024, if that's when they go.
And just to clarify, there on this particular mission, the Europa Clipper, there won't be any probes, correct? And no hope for the really cool submarine mission, right? It's just going to be the flyby with the chance of spectroscopy analysis.
Yeah,
right?
so far no, but that's one thing. Like the Planetary Society has been pushing very hard for a lander to be attached to this mission, in the same way the Huygens probe was attached to the Cassini mission, which flew to Saturn back in the early 2000s. Cassini detached soon after it arrived in an orbiter on Saturn and flew down and actually landed on Titan's surface, and for about 3 hours was actually able to image Titan's surface. And that happened back in 2005, I think. And so the idea of a lander has been pushed very hard, but I think it comes down to, and I'm not certain of this, but I think it comes down to the Discovery class mission, which Europa Clipper is a Discovery class mission according to NASA, and that gives a very specific cost caps, money caps. You can't exceed X amount of money on your instruments and your probe, and that may be excessive to put a lander on there too. Although my personal view would be, CubeSats and microsatellites, the technology is getting much, much better for much smaller. And an idea came out of NC State University about 15 years ago for microbots that would actually be deployed on Mars, and they would just kind of roll to a stop. Gravity would figure out where they went on Mars. It would be dropped from orbit and would land on Mars, and these things that were about the size of golf balls would roll to various different places on Mars and then send back very basic data about where they're at, what the material was that they were touching, where they landed, and maybe a very primitive image of the area around it. So you could conceivably, for not a whole lot of money, I would think, drop a bag of golf balls essentially on Europa,
Yeah. And we have somebody ask, I think this is a great question. Like, do we, as citizens, do we have any control over what NASA decides to do? Like, can we be writing, our Congress people to influence them? Like we want a mission that allows us to study Europa.
Definitely. More. You of course have the power to lobby your legislators and things, and just say, look, we would love, fine, spend the extra $50 million and put a lander on this thing, and it seems like a no-brainer to me, because you're already going there. The really hard work of launching to Europa, the hardest part of all of that is getting the rocket off the ground on Earth. Once you've tackled basically half the problem right there. So what you put on the payload, and it doesn't matter as nearly as much as getting it up off the ground. And again,
Carl, that does answer the question. Carl earlier was asking, what is the size of Europa in comparison to Earth?
Europa's about 1/4 the size of Earth, so kind of like the moon. Okay. It's about 1/4 the diameter of the Earth, it's about the same diameter as our moon. Very close in size to the moon.
Oh, wow. And do you know, will the Europa Clipper use ion engines?
That is a good question. I don't think so, but I could be wrong. Yeah, I'm willing to stay corrected. The actual propulsion and thrust, and what kind of instrument it's going to get launched with, we don't know yet. I have a guess that SpaceX is going to get involved somehow
Oh.
because they're launching a lot of stuff lately. And this would, and it would be more economical. You could spend more money on the lander if you spent less money on the launch vehicle. And that, of course, is something you can do with SpaceX because they can land their launch vehicles, and save money that way. I don't know. Again, this is crossing a line into my opinion versus what we know for sure is fact. So you got to be careful with that.
All right. Well, we have a couple more questions, but if you wanted to continue, I think you can go ahead and we can save some for later.
Okay. Well, you can see on this sheet here. Let me, I guess. Whoops, that didn't help any. Okay. What I need to do is make this bigger. Here. Are you seeing a Europa Clipper concept summary up here?
Yes. Yeah.
Okay.
I think the full page.
Now this is the most recent information I was able to obtain. All right. And there may be a more current version of this as of now, but as of fiscal year 2015, the cost of the mission was about $2.1 billion. Okay. And you can see the payload or the instruments that are actually getting packed in the orbiter here. The ice penetrating radar, of course, so you can see down below the cracks. The
well, sorry. So one of our friends was asking what would be the purpose of that ice penetrating radar? What would they learn from that?
Well, you'd want to find out the structure under the ice, if it's like solid ice from top to bottom, or if it gets into a slushy region near the bottom. Is there differential heating inside the ice where the ice is warmer in some places than in others? You could maybe figure that out from the structure of the ice. How structurally secure is it, if you will? The other thing you could do is determine thickness of the ice, because that's still an open question as to exactly how thick the ice is. And are there thinner places? Is there a good place to put a lander? Because the ice is especially thin there. Or so all of this is going to be key to finding that out. So the ice is really the big question about Europa.
Mm-hmm. And Jenny suggested that you could look for pockets of oxygen. Is that something that could be done?
You could do that with a couple of the different instruments on here, the spectrometers. I'm thinking the neutral mass spectrometer would be especially good at detecting gases in like pockets of oxygen in the ice. And I think Enceladus, another moon orbiting Saturn, has very low concentrations of oxygen being released from the ice. So the interaction of radiation breaking apart the water molecules that make up the ice releases oxygen. So you're going to have some surface oxygen here anyway, not nearly enough to breathe. It's not like you just walk around on Europa. Besides inhaling gas like that, if it was at sufficient concentration, would freeze your lungs at that temperature. And so,
that's so fun.
It would not be fun, no.
Yeah. And actually, you've mentioned Enceladus. Is that is there potential for life on that moon, as far as you know?
Yes. When actually it turns out Galileo, the probe that orbited or flew by Europa, flew through a plume of this ejected water coming out from the inside of Europa. These plumes happen around Enceladus all the time, and Cassini, when it was flying around Saturn, flew through plumes about 10 times and analyzed a lot of organic molecules, including the sugar ribose. The 4-carbon sugar ribose was found in the geyser coming off of Enceladus. So we know that there's simple organic compounds in the water on Enceladus also. So again, another place to look for life. But there are currently no plans to send a mission out there yet.
Gotcha. Yeah, the fact that there's sugar compounds seems really promising.
Yeah. So I'm basically done,
Okay.
because you can read basically 45 flybys, etc. But the mission, part of the problem here with my presenting all this is that none of this is firmed up for sure yet. We know NASA has approved funding for the flying the mission. That we know. We know it's supposed to launch around 2024. Okay, but after that, things get really sketchy. And I'm going to guess in the next couple of years, the technology that's based that these instruments down here are being built with is going to change and get better, of course. Um, and so when they actually start assembling the spacecraft, probably in 2022, they're going to be putting on board the finest equipment they can get for the money.
Mm-hmm.
So all of this, next year's presentation might be completely different than this year's.
Right.
Because a
That would be
lot of you
exciting.
might have lobbied your congressperson, and all of a sudden now we have a lander.
Yeah.
Yeah.
Yeah, that would be so exciting. All right, y'all, let's get to work. Okay, well, we do have a few more questions. So if you don't have more slides, I say we get to answering some of these questions.
Good.
All right, Jasper wants to know, is there a possibility of life on Ganymede?
Yes. Ganymede also has a liquid water ocean, although it's not as thick, if you will, as Europa's ocean. And there seems to be, someone pointed out, a series of layers of water and ice, Remember, Ganymede is further away from Jupiter, even though it's larger, and so the gravity would be stronger. That is mitigated by the distance away from Jupiter. It's a lot further away than Europa is, and so it would be less susceptible to the tidal forces that play havoc with Europa and Io, for example.
Mm-hmm. Very cool. And then is the water here that you were showing us on Europa, is that similar at all to the water on Earth? I guess it depends on, where it is on Earth that we're comparing.
Yeah, you really have to talk about, when you're talking water quality, could you scoop up a glass and drink it? Probably not. There's some evidence for sulfuric acid in some of the water, or some of the organics that are present on the surface. So you definitely want to purify the water, and neutral out the pH in some places.
Mm-hmm.
So it would definitely depend on how good your filtration system was.
Gotcha. And Carol Bart wanted to know, if we do find life, what do you think would happen? This might be kind of opinion based or educated guess based, but
Sure.
What do you think?
I think for a lot of people, it would just put an exclamation point on what they already know. Like, I'm pretty certain that life exists out there somewhere in the solar system.
Yeah.
And we're going to find evidence of it. We might even find it with Perseverance when it starts digging up fossils on Mars, later this year. So, when we find life out there, it's going to, in the same way, when I started teaching Earth science, I was telling my students that we're going to find exoplanets. There will be planets found around other stars. We just don't have the technology yet. We just haven't hit it lucky. We haven't looked at the right stars yet, and our technology still needs work. And within 5 years, they were starting to pull down exoplanets. So the question of, is there life in the universe or not? Probably. The problem is going to be the same problem we're having with a host of other science issues, and that is, the people who are skeptical based on things that have nothing to do with science. Okay. Oh, there can't be life out there because Earth is the one special place where life was created. Poof. So therefore it can't be anywhere else. Okay. So that's going to be a hill we're going to have to climb. As a species, we're going to have to figure out, how to solve that problem. Because once we acknowledge that, there's other living things out there, it makes the next question, going out there and analyzing them and finding out what makes them different. Did they evolve the same way we did? Just using the word evolve turns like 20% of people off right away, right? You immediately shut them down, which is not cool. We got to get past that somehow.
Yeah. And Okay, does Jupiter have a lava moon?
Yes, that lava moon. Anybody know what the lava moon of Jupiter is?
Oh, I certainly do not know. Do y'all know what is the lava moon of
What is
Jupiter?
the
And is
lava
there only
moon?
one? I mean, with 79 moons, I feel like they've got to have multiple.
Well, there's only one that people talk about a lot.
Oh, okay. Okay. Let's see.
There may be more, but there's one.
Io.
One. Yep. It's off to work we go. You know, Io. Io. It's off to work. Yeah,
Okay.
Io is a volcanic moon, so you can imagine the forces that are involved in pulling Europa's crust and ice apart. Well, Io has that going on much more because Io is closer still to Jupiter than Europa is. Io is almost at what we call the Roche limit for a planet or a star, where if you get too close to it, the gravity breaks it apart. But it's right at the edge of that Roche limit, so it can maintain its spherical shape as a moon. But the crust is getting pulled and tugged apart all the time, and all that frictional heat creates a lot of lava and magma.
Mhm.
And that's what we see on the surface of Io is this one big volcano.
Wow.
Yeah.
That's pretty intriguing. Let's talk a little bit about people on Europa, because we've got some questions about this. Okay. So Jasper wants to know, if there isn't life on Europa, could we set up bases there?
Well, I think you have to extend that a little bit and say, well, whether or not there's life on Europa, are we going to explore it with people? And that answer is going to be, yeah, probably. Again, technology needs to take a couple of leaps forward here because you got to get people there in less than 5 years. Now, New Horizons took a straight shot at Jupiter and got there in less than 2. So you can probably get to Jupiter in about 15 months, give or take, depending on when you launch. If you launch when Earth and Jupiter are approaching one another in our orbits around the sun, a time we call opposition, then you solve one of those problems, and that's distance between Earth and Jupiter. You small it down as small as you can get it. And then, the other thing you have to do is solve for Jupiter's radiation, because Jupiter's radiation is a mess. It's very, very intense radiation environment and very, very unhealthy for life as we know it, being fully exposed to it. Now, living under the ice, in an ice cave, would that solve the problem? Well, we don't know if there are ice caves to begin with, but could we make an ice cave and live in the ice cave? That would solve some of the radiation problem. But there are some problems we have to solve before we can put people there, like getting people to Mars first.
Right. Yeah. And Jenny pointed out, what about bone loss? That would have to be solved.
Yeah.
Wow.
That's a serious problem in long-term space flight because of mitigating bone loss. So you'd have to have a spacecraft that has some sort of artificial gravity or some way of keeping your bone, or some medicine that hasn't been developed yet that maintains your bone density, even though you're in a weightless or net zero gravity environment.
And what about Io? Do you think that Io is beneficial to a future colony?
Io, at first glance, you probably don't want to land on Io because Io is a hot mess, and until we figure out Io's tectonics really well, you want to know that the colony you put down is not going to get wiped out by lava tomorrow. And
I would love to have that on a t-shirt. Io is a hot mess.
Yeah, Io's a hot mess.
Covered in lava.
Yep,
I like
definitely.
All right, well, we're gonna wrap it up here in just a couple minutes. So this might be our last question.
Okay.
Do you think that single-celled life is more likely at Europa or Enceladus?
I have no idea. Based on the color of the ice where the cracks are, I would definitely label Europa as being more likely. The other reason for that is that that part of the solar system is denser. There's more heavy metals, if you will, and other heavy elements like iron available in the Jupiter system than there is out at Saturn. And so the materials, the building blocks of life, are going to be more common in Europa than they are in Enceladus. So, it's possible that there could be I would definitely be out of school if I said you can't have it on both, and because that's doable. But it's more likely in Europa. Yeah, definitely.
Okay, and so one last question, and we've gotten
Okay.
some answers to this question in the chat from the rest of our audience, but I just to add you to the list of experts answering. Is there any energy on Europa, like any kind of energy other than radiation?
Okay. Well, again, you've got at the floor of the ocean, where the crust of Europa, the rocky crust, meets the ocean. You probably have, as Dr. Papagliardo pointed out in the video, you probably have tidal heating causing a melting of the crust as well. So you got volcanic vents coming up out of the floor of the ocean, and those would provide the heat energy, and the ions produced there would provide ample energy for living things to harvest and use as an energy source in the same way plants use the sun.
Awesome. All right. Well, thank you so much, Ken, for sharing your expertise with us. Thank you, all of you, for joining us today. Let's see. I also want to say thank you to the NC Space Grant for making virtual astronomy days a thing. Thank you to our friends of the museum members who support us every day. And of course, if you want to get some astronomy days gear, you can go to our website for a t-shirt or a hoodie. Members save 10%. And check out the chat. We've got some links for you. We've got the link for all of the other programs that have happened. You can watch those recordings. You'll be able to find this recording at that link. And you can also find the schedule for the programs that are happening this weekend. So we hope that you can join us again. Thank you again for all of your great questions, and Ken for all of your great answers.
Yeah.
All right, did I get everything? We're going to send you a survey as well. Yeah. Oh, and some Troy said thank you from Florida. Also, you can see the chat now, right?
Yeah. I'm
Yeah.
seeing the.
I agree. Excellent presentation. Thank you, everyone.